Welcome to this edition of Train for Aptitude. Today we look at the third concept in the problems on streams and boats. Let us read the problem. A boat takes 90 minutes less to travel 36 kilometers downstream than to travel the same distance upstream. If the speed of the boat in still water is 10 kilometers per hour, what is the speed of the stream? Based on the problem, we could visualize the scenario as follows. The assumption here is that the stream and the both move steadily throughout the journey. What we need to note here are the journey both downstream and upstream. The boat is assisted by the flow while going downstream, and therefore the effective speed is the sum of the speed of the boat and the water, and this makes the time for journey shorter. The boat, when moving upstream, is hindered by the flow of water, and therefore the effective speed would be the difference of the speed of the boat and water, and this makes the time for journey longer. The unit is inconsistent, and we might need to ensure that it is consistent. We could work out the answer as follows. Given that we know the speed of the boat, the distance one way, and the time to travel in minutes, we can begin by looking at the first step, which is normalizing the units. Since it is in minutes, we would need to get it in hours, and we will retain it as a fraction, that is 3 by 2 hours. The next step is to find the equations for the speed downstream, upstream, and calculate the downstream time and upstream time. This is 36 divided by 10 plus or minus the speed of the stream. The last step is to begin with the difference in time as the time taken to go upstream minus the time taken to go downstream. Note here that the time taken to go upstream is longer, and that is why we have structured it this way. We solve the equation and we find that it is a quadratic equation. We can solve it as the speed of the stream could be negative 50 kilometers per hour or a positive 2 kilometers per hour speed. Since the speed of the stream cannot be negative, we retain it as 2 kilometers per hour. We could generalize the solution. We first begin with finding the given information, and that is represented as speed of boat SD, speed of stream SS, the distance traveled one way SD, and the time taken as T. We noted earlier that the time to travel is in minutes, and every other information is in terms of hour, and therefore we need to normalize it. This would be the first step. Once we have normalized the unit, the next step is to find equations for the downstream time and upstream time as the distance divided by the speed in that direction. The last step is beginning with understanding the equation for the difference in time. Since the time taken to go upstream is longer, we use that and subtract the time taken to go downstream and equate it to the information of 90 minutes given earlier, and then we solve. We have a quadratic equation, and the solution to the quadratic equation would be the answer to the problem.
Thank you for watching Train for Aptitude. Do not forget to encourage us by subscribing to our YouTube channel and liking the Facebook page.